Hi everyone. So now I'm going to talk to you about quasi-experimental designs or non-equivalent comparison group designs. So this is the idea that in the real world, random assignments can't always happen, right? So assigning participants to treatment groups is often not feasible, or sometimes it's not even ethical. Right? So if you're talking to participants who come in and need help with depression, telling them that their treatment as usual group versus, a medication group, that in their preference for which group they want to be in doesn't come into play because they're randomly assigned to groups. So that may not always necessarily be ethical, especially with social work when we're talking about quite a bit about ethics with working with our clients. So it may seem unfair, illogical to assign clients to treatment groups based on random assignment rather than their clinical assessment of what they need. Assignment to receive no treatment can be particularly unappealing to clients and providers, and clients may decide to go elsewhere for services. So quasi-experimental designs are not as highly ranked in research hierarchy as true experimental designs with random assignment, but they can still be quite strong. So there's two different types of quasi-experimental designs. There's non-equivalent comparison group designs, and then there's time series designs. So non-equivalent comparison group designs mirror the same ones as experimental designs, except they do not use the random assignment to create groups. So that R that you saw at the beginning of each of those images does not happen with quasi-experimental designs. And there can be a variety of different strategies that can be used to assign participants to study groups. You may choose to study sites that are roughly equivalent, and one provides the experimental treatment and the other does not. You may assign participants to a certain provider, some of which are providing experimental treatments and others who are not, depending on caseloads. So again, this is an example of a control group, non-equivalent comparison group design, where you do have a pre-test and you do have a post-test and you do have an intervention, but there is no R to randomly assign them to a treatment group or to the control group. One of the things that you really want to ask yourself with quasi-experimental designs is, are the groups comparable? So the key issue in judging the internal validity of a non-equivalent comparison group is whether or not the groups are roughly equivalent. So you want to discuss the equivalency of the study groups, and the degree of plausible equivalence can range broadly. So again, you want to try and find two groups that are as comparable as possible. So you may look at things like client characteristics, age, gender, ethnicity, diagnoses. So you want to, again, make sure that there's not huge age differences in the two groups. You might want to make sure there's not different diagnoses within the two groups, and they're as comparable as possible. So strategies to control for selectivity bias. So groups may be non-equivalent if one of the groups is more motivated to change or already engaged in the change process before treatment is initiated. So one of the things that you can do is a multiple pre-test design study where participants are observed repeatedly to determine whether change in one group is already in process. So this is what a multiple pre-test design already looks like. So this might be one pre-test in month 1, another pre-test in month 2, another pre-test in month 3, and then they get the treatment if they're in the treatment group, or they are the control group and they get either no treatment or just the control treatment. And then they get the post-test after. So if by doing multiple pre-tests, you can see whether there have been changes already happening in one group but prior to the treatment or not. And so you want these numbers to be consistent and low because you want to show that the treatment that is happening is actually going to be effective. Another design strategy that can be used to detect a possible selectivity bias is to provide the experimental treatment to the control group after the post-test. So this is something that's called switching replications. So the control group first receives the treatment as usual, and then following the first post-test, then they also receive the experimental treatment. So this first group, you have, the first is the pre-test, and then you have one group that receives the treatment, and then you have a post-test, and then they receive either the treatment again or nothing, and then another post-test, and you have another group that receives either no treatment, and then a post-test, and then they actually receive the intervention, and then another post-test as well. So this is a design that's called switching replications. So there's other things that you need to do to assess for study flaws. These are discussed in the internal threats to internal validity video that I made. So some similar flaws that can be found are biased measurements, poor treatment fidelity, practitioner non-equivalence, differential attrition, and research reactivity. So these are all things that you will constantly want to keep in mind for any studies. No study is perfect. Each study has strengths and weaknesses, and so it's up to us as the readers to interpret and to determine whether or not a weakness is so egregious that it can wreck the credibility of the findings. So when a study has both pre-test and a post-test scores, it should be used to examine the difference of improvement from pre-test to post-test, not just the post-test scores alone. You want to look and see if there was changes in pre-test and post-test in both the intervention and the control group, as well as the differences in the post-test scores. So studies should also address whether or not the magnitude of improvement is in outcomes is meaningful from a clinical or societal standpoint. So you're looking for something that is statistically significant. So this is where you run all these statistical analyses. But also you want to make sure that it's something that's meaningful for clients, practitioners, and the community as well. So pilot studies are another form of quasi-experimental designs. They are probably one of the lowest on the research hierarchy. They're used as breaking the ice and guiding future research. There's no comparison group. It's usually just a one instance study. And the results should be interpreted with caution because the findings are not should not have a lot of confidence, and there should be a lot of limitations with it, but it usually gets the ball rolling with future research that can be used and that helps to guide future research studies. So even though pilot studies usually involve relatively weak designs, they are valuable if they are evaluated with appropriate level of caution. The stronger studies don't yield results if they don't exist, and findings guide future research or indicate whether more scientifically rigorous studies are needed. So again, this is just something to kind of get the ball rolling for hopefully future more rigorous studies to happen. So I hope you guys have a great week. I hope this has been helpful, and I hope you guys understand some of the differences between experimental designs and quasi-experimental designs. They can use the same design structures, but the biggest difference to take away is the R, random assignment.